This is 4.3D, Simplify Expressions with a Fraction Bar from OpenStax PreAlgebra. So we've been talking about fractions. Now we want to talk about how to simplify fractions when there's more than just a number or a variable in the numerator or the denominator. So first, let's talk about negative signs. Where does a negative sign go in a fraction? And we've touched on this before, but let's go ahead and formalize our concept of this. So it can go almost anywhere. So what does this look like? Up here I have three different fractions, all negative 1/3, and they are all equal. Okay, notice in this first one, the negative sign is out in front of the fraction and it's right in the middle. It's equal with it's not equal, but it's on the same level as the fraction bar. And that is equal to negative 1/3. So on the number line, if we had 0 and we had negative 1, right, negative 1/3, let me switch color here, negative 1/3 would be approximately here, negative 1/3. Okay, so that's where that would go. Over here we have 1/3, but the negative sign is attached to the 1 in the numerator. Same exact thing. We could put an equal sign here. This is equivalent to this, and that is the same thing on the number line. And then over here, the negative sign has moved down into the denominator. Same thing. These are all three ways to show the same value, negative 1/3. Okay, and so what you need to remember is that fractions mean division. Okay, so let's look at what that means in regards to these negatives. And so we know that when we're dividing positives and negatives, we have certain rules. So when we are dividing a positive by a positive, right, because remember fraction means division, that gives us a positive, right? We could also say a positive divided by a positive equals a positive. Okay, those are not pluses, those are positives. And then looking at some of our fractions up here with negatives, this one is a positive divided by a negative. So if we have a positive divided by a negative, remember a positive divided by a negative is equal to a negative. So if you have a fraction with a positive on the top and a negative on the bottom, that equals a negative fraction. This one, the negative is on the top, negative divided by a positive. We could rewrite it as negative divided by let me get the dot there, a positive, right? We know that a negative divided by a positive is a negative, so this fraction is equal to a negative fraction. And then what if they're both negative? That's not up here, right? We don't have a negative numerator and a negative denominator up there. But let's go ahead and write it out. A negative divided by a negative, we could rewrite it as negative divided by a negative. And remember, when you have a negative divided by a negative, that's going to equal a positive. The negatives cancel out. So same thing here. A negative divided by a negative is equal to a positive. Okay, so that's how negatives in fractions relate to division as a fraction. So keep that in mind. You must understand this, that if you have a positive and a positive in the numerator and the denominator, it's a positive fraction. If you have a positive numerator and a negative denominator, it's a negative fraction. A negative numerator and a positive denominator is a negative fraction. A negative numerator and a negative denominator is a positive fraction. I hope I said that all correct. That was a lot of positives and negatives and numerators and denominators, but you get the idea. Okay, so if you don't already understand this, you need to let me know so that I can direct you or reteach you these concepts, because these are very, very important. So let's look at what this is going to look like as an exercise. So it says, which of the following fractions are equivalent to 7 over negative 8, which is equivalent to 7 divided by negative 8. Okay, so let's look at this. If we have a positive numerator and a negative denominator, we said that that is going to be a negative fraction. Okay, so let's look at each of these individually. Here we have a negative numerator and a negative denominator. That's going to lead to a positive fraction. So this is not equivalent to this, so we're going to get rid of that one. A negative numerator and a positive denominator, That's going to give us a negative fraction, and so that is going to be equivalent. So this one is equivalent. A positive numerator and a positive denominator, that gives us a positive fraction. We're looking for a negative fraction, so that is not equivalent. And a negative stuck out in front is a negative fraction. So this one is also equivalent. Okay, so negative 7 over positive 8 and negative 7/8 are equivalent to 7 over negative 8. Okay, now you are going to try some of these on your own. Which of the following fractions are equivalent to negative 3/5? And which of the following fractions are equivalent to negative 2/7? Pause the video, work this out on your paper, and then come back to make sure you did it correctly. Okay, let's go through this. The first one that we are looking at is negative 3/5, and we know that this is going to give us a negative fraction. So let's go through each of these and see if it's a negative or a positive fraction. A negative and a negative is a positive fraction, so this one is not equivalent. A positive and a positive is a positive fraction, not equivalent. Here we have the negative out in front of the fraction, that is a negative fraction, so this one is equivalent. A positive numerator and a negative denominator gives us a negative fraction. This one is also equivalent. Now we're going to look at negative 2/7, and we have the negative stuck out in front. Okay, so this is a negative fraction. Let's look at each of these individually. A negative numerator and a negative denominator, that gives us a positive fraction, so that is not equivalent. A negative numerator and a positive denominator, that is a negative fraction, therefore that is equivalent. A positive numerator and a positive denominator gives us a positive fraction, that is not equivalent. A positive numerator and a negative denominator gives us a negative fraction, and that is equivalent. Okay, so check what you marked on your paper, make sure it is correct. If not, go back and rewatch the section that explains it. So what do you do when there are expressions above and or below the fraction bar? Now, technically, a number is an expression or a single variable is an expression, but we're going to talk about more complex expressions. So for example, if you have 4 plus 8 over 5 minus 3, what do we do with that? What you have to remember is that fraction bars act as grouping symbols. Therefore, you have to simplify the numerator and the denominator before dividing. So if you remember when we talked about order of operations, we talked about PEMDAS. PEMDAS, right? And the first one was parentheses. But I mentioned that some people call it GEMDAS. GEMDAS for grouping symbols. Parentheses are a type of grouping symbols, and there are more, and we did go over these. So there are parentheses, there are brackets, there are braces, and I'm horrible at drawing those, sorry. Okay, braces. Absolute value bars are also grouping symbols, and now we're going to add on here fraction bars. So if you have anything on the top of a fraction and anything on the bottom of a fraction, okay, this is considered a grouping symbol. So you're going to do what's on the top first, then you're going to do what's on the bottom, and then you will divide because of the fraction. So let's go ahead and write this out in order as steps. How to simplify an expression with a fraction bar. 1, simplify the numerator according to PEMDAS. Next, simplify the denominator according to PEMDAS, and simplify the fraction. Now, as you get really good at this, as you get good at this, you will do these two steps concurrently at the same time, but you must understand the order before you start trying to do them at the same time. So let's do some examples. We're going to do 4 plus 5 over 5 minus 3. That's the one that we had on the previous slide. So first we're going to, according to our slide back here, first we're going to simplify the numerator and then the denominator and then simplify the fraction. So let's simplify the numerator. The numerator is 4 plus 8. 4 plus 8 is 12. And I'm going to divide that by 5 minus 3. 5 minus 3 is 2. Okay, so I have my simplified my simplified expressions on the numerator and in the denominator, but now I have to simplify that fraction, right? So I can think of this as 12 divided by 2, which I know is 6. So if I think of it that way, 12 divided by 2, that equals 6. Or I can think of it as still as a fraction and think, oh, 2 is a factor of 2, and 2 goes into 2 one time, and 2 is a factor of 12 and goes into 2 6 times, and that leaves me with 6 over 1, which is equal to 6. Okay, either way I get to the same answer. So however your brain wants to think about it, do it that way. Okay, so let's look at the one on the bottom. This one's a little more complicated because it has more steps and it has more than just addition and subtraction in the numerator and in the denominator. So remember, we're going to simplify the numerator first using PEMDAS. If it helps you, write that out on your paper as you're working. PEMDAS. Okay. So in the top, in the numerator, we have 4 minus 2 times 3. So there are parentheses in the top, but there's nothing inside the parentheses, right? This P means to work inside the parentheses. So we don't have to do anything. Next, exponents, there are no exponents in the top. So we're going to multiply in the top. We have multiplication here. So this gives us 4 minus 2 times 3 is 6. Okay. So we've simplified the numerator. Now we're going to simplify the denominator using PEMDAS. Okay, there are no parentheses in the bottom, but there are exponents, so we're going to do that. So we have 2 squared. It means 2 times 2, and so that is 4 plus 2. Okay, so we've started simplifying the numerator and the denominator. We've done one step in each, but notice we can still simplify each one more. So let's go ahead and do that. 4 minus 6 is equal to negative 2. 4 plus 2 is equal to 6. Okay, so now I'm down to a fraction with a single number in the numerator and a single number in the denominator. But I can still simplify this, right? This is not in lowest terms. 2 is a factor of 2 and it's a factor of 6. So I'm going to divide 2 into 2, and that goes 1 time. Divide 2 into 6, and that goes 3 times. So I'm left with negative 1/3. Now, I chose to put the negative up there, but remember, you could have also put it out in front. Negative 1/3. Technically, you could have put it in the bottom as well, but generally you don't put it this way. You either put it this way or this way. Okay, so let's have you guys try some of these on your own. So you are going to simplify 4 plus 6 over 11 minus 2 and 6 minus 3 times 5 over 3 squared plus 3. Remember that you are doing the numerator first and then the denominator, but within each of those you are following PEMDAS. So pause the video, work it out on your own paper, and then come back. Let's start with the top one. So we're going to do the numerator first. 4 plus 6 is 10. 11 minus 2 is 9. Okay, so I got everything reduced down to just one term on the top and one term on the bottom. And now I need to check and see if this is reducible. I have 10 and 9, and there is no number other than 1 that will divide into each of those evenly. And so I'm going to go ahead and leave it like that. Remember, in algebra, you want to leave an improper fraction. Okay, now technically this does equal 1 and 1/9, right? But that's a mixed number. We do not want things in mixed numbers in algebra unless it specifically says so, or unless there's a specific reason to do so. You generally want to leave things as improper fractions. So in your homework, you should leave it like this. Okay, let's go ahead and do the next one. So first, we're going to work in the numerator. And there are parentheses here, but there's nothing to do inside the parentheses, so we're going to move on. There are no exponents in the numerator, so we're going to do multiplication first. 6 minus, and then 3 times 5 is 15. Now we're going to work in the denominator. So we don't have parentheses in the bottom. We're going to skip over that, but we do have exponents. 3 squared means 3 times 3, so that is 9, and then just copy this over, plus 3. Okay, now I'm going to work in the numerator again. 6 minus 15. Okay, ooh, I'm going to end up with a negative number because I have a smaller number minus a bigger number. Okay, so 6 minus 15 is equal to negative 9. 9 plus 3 is equal to 12. Okay, so now I have a fraction with one term in the top and one term in the bottom, but I need to check to see if that is reducible. I notice that 9 and 12 are both divisible by 3. So I'm going to divide them each by 3. 3 goes into 9 3 times. 3 goes into 12 4 times. So that leaves me with negative 3 divided by 4. Negative 3/4. Okay, check the answers that you got on your papers and make sure that they match mine. If not, go back and either watch the directions on how to do this or look step by step and see where you made your mistake. Let's do 2 more examples, and these are getting more and more complicated as we go along. And so the first one, we have on the in the numerator, we have parentheses, stuff to do in the parentheses, and we have exponents. Down here, it looks the same. We have things that are squared and we have minus, same numbers, but the order is going to be different. This is why it is so important to follow our order of operations. PEMDAS, there we go. Okay, so let's work in the numerator first. We're going to do parentheses first, inside the parentheses. 8 minus 4 is equal to 4. And then we need to leave that squared there. We haven't dealt with that yet. Okay. On the bottom, we don't have any parentheses, so we're going to go straight to the exponents. If you want, you could just rewrite this out here like this so that you're doing the exponents on the top and the bottom at the same time. So you could do that. So let's go ahead and do our exponents. 4 squared is equal to 4 times 4. 4 times 4 is 16. 8 squared is equal to 8 times 8, and 8 times 8 is 64, minus 4 times 4, which is 16. Right? So now we want to deal with, there's no more steps to deal with in the numerator, but what we want to deal with is we want to deal with the subtraction in the bottom. So let's go ahead and subtract that out. We're going to carry the 16 over here, just copy it over. And we have 64 minus 16 is 48. Okay, so we have 16 divided by 48. 16 divided by 48. Now, I know, because I use numbers a lot, I know that 16 is a factor of 16 and 48. Okay, so if you know that, you could jump to this. 16, 48. 16 is a factor of 16 one time. It's a factor of 48 3 times, and you could get 1/3. A lot of you will not just automatically recognize that. So you're going to have to look for another factor. Okay, so let me rewrite it over here. The easy one would be 2. 2 is a factor, but I'm going to jump to 4. Okay, I know that 4 is a factor of 16 and 4 is a factor of 48. So I'm going to take a 4 out of each of those, and I'm going to get 4 on the top, and 4 goes into 48 12 times, so I get 4/12. Okay, so now I have a fraction, but I see that it's still not reduced. Okay, so I'm going to look at this. 4 is a factor of 4, and it's a factor of 12. 4 goes into 4 one time, 4 goes into 12 3 times, and I get 1/3. So notice, no matter which direction I went when I reduced, I ended up with the same answer. Okay, if I would get the same answer if I'd started with dividing out 2's. I'd get the same answer if I started by dividing out 8's. Okay, as long as you pick numbers that are factors of both the numerator and the denominator, you will eventually get down to the same answers. Okay, the next one. 4 times -3 plus 6 times -2, all over -3 times 2 times -2. So let's go ahead and work this one out. We are going to do, there's nothing to do inside parentheses, so we're not going to do that. There are no exponents in this one, so we're not going to do that. And we're going to move on to multiplication. So multiplication here, these two are right against each other, so they're multiplied. 4 times -3 is -2. And then we're going to add 6 times negative 2, those are multiplied, is negative 12. That's all over. Negative 3 times 2, negative 3 times 2 is negative 6, minus 2. Right? This is multiplied because it's in the parentheses. That shows that the 6 and the negative 2 are multiplied, but here we're subtracting 2. If they wanted us to multiply by negative 2 down here, they would put parentheses on either side of that negative 2. So in this case, it means minus. Okay, so now we've done the multiplication. There's no division in the numerator or the denominator, so we're going to move on to addition and subtraction. On the top, we have negative 2. Sorry, that should be a 12. I wrote that wrong. I said 4 minus 3 is negative 12. So negative 12 plus negative 12. We could also rewrite this as negative 12 minus 12, right? And those two together are equal to negative 24. On the bottom, I have negative 6 minus 2. That's equal to negative 8. Ooh, this is the first time we've seen this, where we have a negative on the top and a negative on the bottom. Remember, when we have a negative divided by a negative, it's going to equal a positive. We can cancel out those negatives. If they're on the top and the bottom, we can cancel them out, okay? As long as you cancel the same number out on the top and the bottom. And then I'm going to reduce this fraction. I can see that on the bottom I have an 8. 24 is divisible by 8, so I'm just going to use 8 as my factor. 8 goes into 8 one time, 8 goes into 24 3 times, and I'm left, after I get rid of all the cross out things, I'm left with 3 over 1. And then while this is a correct answer, you still can reduce this even more, you can simplify it even more, and that's going to be 3. Okay, so that's how you would simplify these more complex problems. Okay, I'm going to put up 2 more try it problems for you to try on your own. Go ahead and pause the video, work them out on your own. If you need to re-watch the part that I just did, the example I just did, and work these out step by step while I'm working out the example ones step by step, then go ahead and do that. Come back and check your answer when you're finished. Let's start with the top one. So I'm going to go ahead and rewrite PEMDAS up here just for my reference. Okay, so first, things inside parentheses. Right here I have 11 minus 7. 11 minus 7 is 4, and then I'm going to keep the squared. And then I don't have anything inside parentheses here, so I'm just going to carry that all over. I'm going to copy it over so I'm doing all the exponents at the same time. 11 squared minus 7 squared. Okay, now I'm going to deal with all those exponents. 4 squared is equal to 4 times 4, which is 16. 11 squared means 11 times 11, which is 121. I'm going to subtract 7 squared, which means 7 times 7, which is 49. Okay, and then the top, there's no more simplifying to do in the numerator. I'm going to bring that 16 over. But I need to subtract 121 minus 49. 121 minus 49 is equal to 72. Okay, now I want to see if I can reduce this. Are there any factors that go evenly into 16 and evenly into 72? This is where your multiplication tables are going to come in handy. And I recognize that 8 divides into 16 evenly and 8 divides into 72 evenly. If I didn't notice that right away, I could definitely start with 2, right? I know 2 will divide into 16 and 72 evenly because they both end in even numbers. But I'm going to go ahead and do 8 just to reduce the number of steps that I have to do. 8 goes into 16 2 times, and 8 goes into 72 9 times. So I'm going to rewrite that over here, 2/9. And then I'm going to check, are there any factors of the numerator and the denominator that I can still take out? There are not. So this is the reduced simplified fraction. And our last one, we have 8 times negative 2 plus 4 times negative 3 all over negative 5 times 2 plus 3. So I'm going to start, I don't have anything to do in the parentheses or in the exponent, or there are no exponents, so I'm going to start with multiplication. So let's do the multiplication in the numerator first. 8 times negative 2 is negative 16, and I'm going to add 4 times negative 3, which is negative 12. On the bottom, my multiplication is negative 5 times 2, negative 10. And there's nothing to do with that 3, so I just copy it over. Okay, so I've done all my multiplication. There's no division in the numerator and there's no division in the denominator. Now we know we're dividing the numerator by the denominator, but remember we're doing everything in the numerator first and then everything in the denominator, and then we're dividing because the fraction bar is a grouping symbol. So let's go ahead and do our addition. Negative 16 plus negative 12 could also be written as negative 16 minus 12. However you prefer to look at that is fine with me. Okay, so we have a negative number and we're taking away even more, which means we're going to have a negative. And then because they have the same symbol, they're both negatives, we're going to add those. So it's negative 28 and negative 10 plus 3. So we have a bigger negative number and then we're adding a smaller positive number. So we're going to have a negative, and 10 minus 3 is 7. Okay, once again we have a negative in the numerator and a negative in the denominator, so we can get rid of those, because a negative divided by a negative is a positive. And now I need to see if I can reduce this fraction. I have 28 on the top and 7 on the bottom. So what factor would go evenly into 7 and into 28? Well, it's 7 itself. 7 goes into 7 one time. 7 goes into 28 4 times. So I can rewrite that as 4 over 1. And then that can be simplified to 4. Check your answers. Make sure yours match mine. If not, go back through, see where you made your mistakes. Check Google Classroom for your assignment. And please don't hesitate to ask me any questions.